Random variable y1 is equal to e power x1 characterizes insurer's annual property loss, where x1 is normally distributed with mean 16 and standard deviation 1.5. Random variable y2 is equal to e power negative x2 characterizes liability losses, where x2 is normal with mean 15, standard deviation 2. Annual property losses are independent of annual liability losses. Calculate the probability that in a given year, the minimum of the insurer's property losses and liability losses exceeds e power 16. So we're talking about the minimum. So let Z be the minimum of the two losses. So Z is the minimum of y1 and y2. And we have to find that the probability that the minimum exceeds e power 16. So probability Z greater than e power 16 is what we need. So that would be probability. So the minimum of two numbers is greater than some number if and only if both the numbers are greater than that number. So Z will be greater than e power 16 if and only if both y1 and y2 are greater than e power 16. And because of independence, the and changes into multiplication. And we get probability y1 is greater than e to the 16 times probability y2 is greater than e power 16. And y1 was e power x1, so substitute that. So that becomes probability e power x1 is greater than e power 16. And similarly, y2 was e power x2, so that becomes e power x2 is greater than e power 16. And now you can get rid of e's on both sides, so that changes into x1 is greater than 16, and the second one changes into x2 is greater than 16. And now we are given that x1 and x2 are normally distributed. So to find these probabilities on the right side of equation 1, we need to change 16 into standard score for each of the two variables x1 and x2. So we know that standard score equals x minus mean over standard deviation. So z1, which will be the standard score of the 16 that corresponds to x1. So that would be 16 minus the mean. And for x1, the mean was given to be 16. We look in the problem. X1 is normally distributed with mean 16, standard deviation 1.5. Therefore, x is 16 because of this 16 minus 16, which is the mean, divided by 1.5, which is standard deviation. That's 0. And similarly, for x2, we are given that the mean is 15 and the standard deviation is 2. If we go back, x2 is normally distributed with mean 15, standard deviation 2. So here the 16 into a z-score becomes 16 minus 15 over 2. That's 0.5. So equation 1 now becomes probability z greater than e power 16 would be probability z1 greater than 0 times probability z2 greater than 0.5 because of these two equations. And as we know that the table goes in the less than direction, so we change this one into 1 minus probability z1 is less than equal to 0. And this one becomes 1 minus probability z1 is less than equal to 5. So probability of z1 less than equal to 0 is 0.5 because remember, half of the values are less than equal to 0 and half the values are, so z is equal to 0 is in the middle of the standard normal curve. So whether you're going less than equal to 0 or greater than equal to 0, it's 0.5. And for the less than equal to 0.5, let's look in the normal tables. Okay. SOA tables. So for 0.5, it's 0.6915. Therefore, go back, have 0.6915, and all of this is 0.154. That is choice B,